Welcome to the bite-sized sessions of the Innovation Award. We just had the Innovation Awards in the keynote session. We had 3 nominees, and today, like in this session now, they're going to show their project, the technicalities behind it, because a 1-minute video is a bit short, but enough to vote for it. And now we're going to deep dive a little bit, because 15 minutes is also still pretty short. We're going to start with Open Rewrite by Modern. Tim, the floor is yours.
Thanks. So hi everyone, this is going to be like a 15-minute very quick run through of what you can do with Open Rewrite and Modern. If you do want to learn more, then of course just reach out. I have a blue shirt, I'm pretty recognizable. We're going to do this, so should be fine. First of all, of course, honored to be nominated, honored to be, so get so many votes throughout the room and all of that, so that's, really great to see. If you don't know me yet, this is me, Tim de Beek. I like to get dirty when I mountain bike in the woods. I like to hurt myself when I boulder. I like to hurt myself when I hike. I'm not very cautious when I do my hobbies. But when I am at work, then you can see that I do a lot of open source development, mostly on Open Rewrite, or using Open Rewrite on other projects. It's just something that I grew from a hobby during those years where you couldn't get out much, and then they kept asking me if I wanted to join the company, and now I work for Modern, so I get to work on Open Rewrite full-time, which is very neat to do. Now, if you're not familiar with Open Rewrite is a safe code refactoring framework that allows you to modify your code to make it upgrade to a newer Spring Boot version, upgrade to a new Java version, change those properties, they keep renaming, all the pain that you know from having to maintain an application, you can automate that away with Open Rewrite. It's a open source framework, mostly implemented in Java. If you go to our GitHub page, you can find all about how we've implemented this with compilers and parsers and modeling the code that you have, and being able to then visit that model with a visitor pattern and modify, transform it, write it back out again, such that your application gets migrated. So it's a very cool project to work with. We're thankful to be nominated for the Innovation Award with that. And we also see it being integrated into tools from others. So you probably, if you've been reading the news a bit, then 2 weeks ago, I think GitHub came out with a GitHub Copilot Upgrade Assistant for Java, which is just Open Rewrite, but then with a bit of GitHub on top. There's also the Amazon Q Code Transformator, which also is just Open Rewrite with a bit of on top. And then there's the Microsoft, or no, what was it? The Broadcom Application Advisor, which again is just Open Rewrite with a bit on top. So if you want to get to the core of it, then that is this. On the left, we build up a model of your code, and then we enrich that model with transitive dependencies and any kind of type information that we pull from there to be able to have a detailed model of your code that you can then inspect, maybe extract some information for, use that to inform your choices, and then modify that model to as you see fit for whatever purpose you have. Typically, that's upgrades, but we also see a broader use case, that a set of use cases that our customers come up with and users, which I'll share about in a second. Now, we have support for Java, where we started out since 2016. But there's a lot of additional languages that we're adding recently. So if you're using Groovy or Kotlin, you can already use the Java models that we have for a couple of years now. But recently we're expanding into TypeScript, JavaScript, Python, C#, and a couple others to bring this transformational technology to other ecosystems as well. So that's very neat, and we see that used for a number of use cases. So often folks come to the project for use cases like, I have a Spring Boot application, I want to upgrade it to the latest version, and then they Google that, and then they find Open Rewrite, and they discover that we can automate that in a large part. So that's the top left corner. And it's not just upgrades as well. If you want to switch between application frameworks, or you want to switch between testing libraries, assertion libraries, we can automate that change as well to bring you from A to B rather than from version 1 to version 2. And then beyond that, we have use cases more geared towards security, where we can tell you that you're using a 8 levels deep transitive dependency, it is a vulnerable version, and you should be using a newer patch version. And then we insert a code snippet to override the managed version that you have to get you on a safer version. And that's something that other tools just can't do. They don't have the smarts to maybe even detect that, or if they were to detect it, they don't have any way to make that code change for you. But through the insights that we have about your code and being able to insert code snippets, we're able to actually affect security issues there. And then beyond that, we have some recipes where it's not just the fact that you're using a dependency, but more how you're using it. So how are you using that API? And we're also able to find vulnerable patterns there, recognize them, and transform them into the safer alternative, just to make your code more secure. And then another big cluster of recipes that we have is more gained towards code quality. So if you've been using a tool like Checkstyle, PMD, Sonar, something for a decade, and it's been yelling at you every time you get something wrong, we instead have recipes to help adopt the patterns that they recommend or enforce that you use. So if you have 10 years of technical debt and you want to make a dent in that, just run a recipe and you'll see those issues fully disappear from your org. And then you can do really cool stuff enforcing that going forward, meaning that those issues don't pop up again. Now beyond that, there's some more use cases like phasing out feature flags or applying best practices for logging frameworks, testing frameworks, all things you can do through existing recipes. And then, of course, there is also a company attached to it. So if you paid close attention to the logo for Open Rewrite, it's a bit of an R. But if you look at the Modern logo, it is very similar. But a lot of folks have not figured out that we are the main contributors, maintainers of Open Rewrite, even though it's just the same logo, twisted sideways 90 degrees. So there I am explaining that there is the commercial part of it, Modern, and then there is Open Rewrite that others built on top of. And you can see that very nicely in the next slide, where on the left you have Open Rewrite. Again, Apache license open source project. You can run it for free on your own PC tomorrow. It is even integrated into the JetBrains Ultimate Edition. So if you have that, you already have Open Rewrite on your computer. You can already run recipes with the click of a button right on your PC. And if you want to use our open source plugins for Maven and Gradle, then we have those in the top left corner as well. And then there's other tools, like I said, Broadcom, Amazon, Microsoft, all of them coming out with integrations of Open Rewrite. But what none of them have is what is unique on the right-hand side, which is that blue box, where we are able to build up a model of your code and then save it to disk. Because on the left, if you build up a model of your code, that could take 10, 15 minutes, depending on the size of your project and how many external dependencies you have. And that's just going to take a while before you're able to run even one recipe. Whereas on the right, we serialize that model to disk, we build it up ahead of time, and if you have 1,000 applications, suddenly you can run 1,000 recipes across those repositories in just a couple of minutes. And that is something that our customers use to then maintain very large organizations where they maybe have a breadth of Java versions, Spring versions, things they want to be upgrading, and we make that very easy for them. And that we do mostly through the Modern platform, where on the left you can see we can give them insight into where they stand. But the neat thing here is that blue upgrade button that you see on every insight that you have. Because it's not just going to tell you what you're using. It's also going to recommend that you press that button and you get a couple dozen pull requests, or a couple hundred, or even a couple thousand pull requests to upgrade your applications to that latest version across the entire org, such that tomorrow that central chart is going to look very different. And then you can start to track new goals. Maybe you want to move to a cert J and improve the code quality. All things that you can do through this platform to make it really easy. And then also we automate all of the follow-up. So if you create a set of pull requests through this platform, you can send one link to a colleague where he can mass review all the changes that you've proposed to make, mass approve, and mass merge them through this platform. And that's something that I can throw into a quick demo, and we're going to switch screens and see how long that takes. Mirror. No. Not what I hoped. Yeah. So what you can see here, come on. What you can see here is that we have a recipe, the common static analysis issues, and you can run this on your own machine as well, where we have a ton of issues that are reported from other tools, along with the specification identifier that they give you. So in this case, let's open just one where they say, well, string literal should be placed on the left-hand side when checking for equality. So you have other tools that tell you exactly you're doing things wrong because this is nullable and it's going to blow up in your face when you do an equals comparison. What you should be doing instead is flip it around. And then we, instead of going to yell at you, actually have the fixes to make it so. And not just for this one case, but all of these dozens and dozens and dozens of cases. And what you can then do is you can run those one at a time on your own project, or you use this platform to help maintain open source projects, or maybe your own software if it's in there. And then very rapidly you see that you get proposed changes that you can go into and see a bit of the changes that we were suggesting here. And you can see it's all the boring stuff that Sonar has been yelling at you for. So in this case, inline that immediate value, if it's just immediately going to be returned. Don't use final private, that just sounds odd. Just use private final as you're used to. Maybe remove those arguments when they're not necessary. And a lot of things that are just gonna help improve the quality of your code. And if you're ever wondering, then we have a button to explain why we did this exactly. Now, this looks good. I think we can press a click here, and then we start to open a pull request against Spring Retry to help move them away from all these vulnerabilities. But what I like a lot better with this platform is to select all of them and create pull requests for 97 projects to fix all of their static code analysis issues. So that is pretty neat, I think, to help maintain your code. And we can even look at the summary tab here, where you can see that we ran this recipe. We ran against 243 repositories. It took us under a minute so far to save 319 hours of time savings, as usually calculated by a tool like Sonar. 339, we're still going, and pretty soon you'll see that we just were able to really affect change across a large organization and do the follow-up from there. So that is pretty much how you use that platform, and then beyond that, there's some more things that we could be doing. Like I said, those insights, you can click on them, you can make it so that everything upgrades to Java 21 in this case, for all those Netflix and Spring repositories. And what we also have is a recipe builder, because oftentimes we find that folks, they have their own specific needs and they want to change things. How am I doing on time? Minute left. So if you want to customize your own recipes, you can search for them here. And then for there, maybe you want to change or rename an internal dependency, compose it here, add the arguments, download that recipe, and then you have your own startings of an internal recipe. If you want to add existing recipes to that, then you can do like a search for Spring Boot 3.x. And we're going to apply some best practices for Spring, and that gets you some of the recipes that we maintain. To be exact, it's going to be 2,578 recipes that we maintain to help upgrade your application to the latest Spring Boot version. And I can really recommend getting like a touch screen where you get to play around with all the recipes that we can run for you. And then press run, and you'll have all of those fixes applied to your project, suddenly getting you onto Java 21 and Spring Boot 3.3. So that is pretty much what you can do with this platform. And there's some other use cases still, like integrating it into your CI pipeline, such that you apply these practices as you code. You get a helpful code suggestion instead of a big red X. And that, we think, is the way that you should be maintaining your project going forward. If you want to learn more, then here's some helpful links. There's like the docs that we have. You can learn more about Modern and the platform that I showed you. And of course, Open Rewind, if you just want to use the open source parts, that as well. And we have a QR code where you can read about how we are using AI in this space. I gave a talk earlier today, but there's also an ebook that you can read if you prefer that medium. And with that, I just want to thank you all for your attention. Yes?
Tim, thanks so much. Where were you when I still was developing 7 years ago? Because there was always manual labor.
7 years ago, I think we were colleagues there.
Yeah, exactly.
But yeah.
Doing amazing stuff now. Thanks so much.
Yeah, sure.
So, Ruud, can I join you? Can I ask you to join me up on the stage? Big hand for Ruud from the police.
Well, thank you. So, first of all, congrats to the NS with the winning of the award. Too bad it was for us, but who knows next year. Well, welcome to our presentation. I'm Ruud van der Gijp, product owner of Secure Data Services and lead engineer at Cluster Cloud Big Data from the police. I would like to share what we've built over the past year. Over the last year, I've given dozens of presentations about SDS, but I never have done this in English. It's my first, so please be patient, be kind. A year ago, we began building our Kubernetes platform on our secure data services store. Does it work? Come on. Manual. Yes. As the Cloud Big Data department under the infrastructure organization, we're responsible for delivering big data solutions to the entire police force. Within the police organization, multiple container and virtualization platforms serve different user groups. We were already delivering software as a service with Kubeflow, and we were familiar with the big data stores on OpenStack. With our passion for open source and containers technology, we choose vanilla Kubernetes for securing data services because our target audience extends beyond data scientists, and we want to minimize virtualization layers to enhance performance. Our organization is large, very large. With 60,000 employees spread across the country, many of the organization units require data stores to support their work. This is an organogram of the Dutch police. And if you know the right channels, you can access various standard services from the infrastructure organization. If your request deviates too far from standard options due to architectural or functional needs, you will need the right people, the right resources, and machines to deliver the service yourself. In the slide, you see all the areas marked in red. In some way, require data stores. Some of these areas consist of over 100 DevOps teams. You see the one in the right and one here. High-tech crime is also a very big consumer. The infrastructure organization is outlined in red, so there we are. And Team Indigo, which initiated secure data service, sits 3 levels below. This structure results in decentralized standard products being used across various parts of the organization, and service level differ. As Cloud Big Data, we used to deliver custom services. The entire process began with an intake with the process line manager, and a common tactic for delivering planning was delaying the intake. We provided products configured as code to suit the needs of the end user. If agreements could be reached on various technical arguments, additional options like 27 support and high availability were possible. Some requirements weren't set up as standard, and that would require users to write scripts or make extra arrangements with other departments. If you wanted to use Elastic, for instance, you would receive an Elastic server, and then you would be on your own. So there are quite some things customer would need, and they still have to do that themselves. Our organization wanted even more. With security integration and prevention of legacy software, additional delivered needed to be faster and more flexible in our way. All in all, delivery a quality service and achieving user satisfaction was quite stressful. And then came secure data services, and we raised the bar even higher. So this is what we now currently offer, and what makes us then within the police. If we do this all for free and all available in minutes, the coolest team in town. When we all start delivering all these features, we were receiving messages all around the organization. It's always nice to receive these ones. And the last one is my favorite, because I would have more than once get to a question, where can I find your intake process? Well, there is none. And at that point, we knew we had started a movement. You've seen that the data stores used are spread across various parts of our organization. And because we set such high standards and the store allows for great flexibility, it's no longer necessary to create data stores environments throughout the whole organization. There's now one single platform where all users can access and configure their software. Moreover, we no longer need to convince users to adopt a platform. It spreads like a wildfire. So, this one. What technology did we use for SDSL? So, all components within the store are used to use bare metal. meaning there are no additional virtualization layers between the product and the physical machine. All our disks are local, and there's no distributed storage within the cluster. The SDS store configures a namespace for the user by generating a unique YAML file, and this YAML is stored in GitLab and forms our Helm chart that is deployed by Argo CD. Argo then communicates with various operators within the Kubernetes cluster to create the desired products, and that's all within minutes. Here's a simplified example of the SDS store form for creating an Elasticsearch environment, which can also be used through an API. The user has the option to assign an authorization group at the top, and he can activate Fleet within Elastic or APM and choose the preferred capacity. When developers are asked about the desired capacity, the response is usually, I want everything and I want all. Thus, the end users are often surprised they're allowed to set the slider all the way to the right. So they can set the pods and CPU themselves. After at least a month of monitoring metrics, we determined the new capacity based on the maximum use capacity. This new scaling is ultimately calculated and implemented by the Java store. And users are notified by email of the change, and this makes room for new users. Another unique component is the ability to configure the network. This is no real data, so that's okay. When creating an environment, it's not accessible by default. Users must specify which network segment they wish to open. This has become possible because we use Cilium for network policies within the Kubernetes cluster, making net configuration as straightforward as software configuration. The SDS store knows the available networks within the police and which combinations are permitted. And that all is applied in seconds. In addition to configuration, the SDS store, it uses Cilium to show the users which network segments are oversized, unused, or where network traffic is dropped, aiding SDS greatly in our journey into Zero Trust. So is the SDS store really necessary? Don't users have enough with the standard installation and occasionally admin-driven updates? Well, the graphic shows the number of Git commits in the SDS store over the past year. The sudden increase you can see in September, it showed us because we began actively informing users about unused networks. This led to hundreds of subnets being close to connection, and that's something we never could have done before with other network techniques. Centralizing software and data has also led to organizational centralization as well. Specialists are now collaborating, environments are being transferred, and administrators have more time for innovation. First, it started with Indigo, Team Indigo, then a second team joined, Space, and later a third team, Sky, joined. Indigo now provides data stores, Space provides the container platform, and Sky has begun to deliver Metal as a service. Due to continuous demand for more similar systems, we grow very fast. We're seeing deeply automated being adopted by our supporting teams. There's no need to request individual service anymore, we just consume racks. The container team has also progressed by labeling various hardware, such as different disk types, making them available in the store, and this makes it now a joint effort for all teams. Am I in time? Okay, talk quick. The biggest challenge for SDS is now its popularity. In the graph above, you can see the number of namespaces created by users. At 70% of our capacity, it's no longer possible to create new environments. So it shows a message in a store indicating that we are at capacity. This ensures existing users there's still room to grow, scaling down, archiving unused environments, and adding new hardware are ways we manage capacity now. We're also seeing an increased demand for faster storage. In the project's early months, we could still engage with each user directly, but we've since automated customer contact in the store. For instance, we now follow Google SRA standard that downtime under 1 second isn't communicated in advance. thanks to Celium's failover and load balancing techniques. The slide shows that we still need to do for patching the data stores. You see on the left the YAML, and there's a new version of Elastic deployed. It's deployed through a pipeline and it's tested end-to-end before going live in the cluster. The users have 4 weeks to test the new software and initiate an upgrade in the store. If they don't initiate an upgrade, the store activates an upgrade through the operator after 4 weeks. So running legacy software is no longer an option. For backups, we use the standard facilities provided by the operator, with a preference for S3. Restoration is performed by the store using the previous saved configuration file and actually backed up data to recreate the environment. This also provides a simple method for users to simulate a disaster recovery. To scale capacity to maximum usage, the store calculates a proposal, you see on the left. This proposal, based on collected metrics, sets new values for requested and limit on namespaces. Those are also applied directly. In the future, we will continue on a path towards zero trust security by further developing data classification, reducing those network segments, and enhancing network integration with the rest of the police. We will expand our product portfolio with MariaDB and Redis, and we work on a multi-data center environment, and we will become OpenShift compatible. Then the last slide, it's a new campaign. We need the best of the best. Please contact us if you want to join us in our movement. That's it. Thank you for your attention.
Thanks so much, Ruud.
The next.
The next, I would like to invite you up on the stage, or down on the stage, actually.
Thank you very much. Thank you for winning. Thank you for the presentation before. It would be really awesome to have such a platform at NS. We don't have that yet. It would really improve our speed as well, and improvement. I'm Robert. I'm one of the tech leads with the bijsturing teams for the front end specifically, and you are?
The tech lead for the back-end team, pretty much.
Just a small recap on what we are doing. NS is not just the Dutch railways. We are doing far more. We are also operating our own service stations for the trains. We are creating software for our train drivers, which is called TimTim, which they know how when trains are in front of them, how much delay they have, and where they will arrive on what platform. And every year we have the Dutch Grand Prix, where everyone within NS is focusing on getting all the people to Zandvoort and back again, even passenger information. We are servicing all our rolling stock once again, so that no interruptions will happen on that specific day. Some numbers. We have like 300 stations that we are operating with passenger informations and trains. 1 million passengers a day, and we have like 6,000 train movements every day. And that's all supported with like 2,500 people of IT. And everything is running smoothly all the time. You all know that. We have never disruptions. We have no things that are going wrong. Unfortunately, that isn't true. And that's where the bijsturing comes in. Bijsturing is in 3 parts. We have the bijsturing for our rolling stock. That's what we are, and that's the project that we did. We have the crew planning and the crew dispatching, and then you have the part on the yards themselves. So that's how we park trains, that's where we service trains and maintain them. So during a crisis or during an disruptions, these three of these parts need to work together to make a new plan. So for example, there's a disruption between Ede-Wageningen and Utrecht. No trains can run from A to B. We need to make new routes for people so that they can still go. We need to rent buses, and we need to turn around trains at Ede, turn around trains at Utrecht, so that everything is running smoothly again. And at the end of the day, we still need to make sure that all the trains are getting serviced, getting cleaned, and so that they are ready for tomorrow again.
Yeah, and that's where the BOM software comes in. And this is an image of the old stuff that the bijstuurders, our users, used to use. A lot of problems with this software. I won't even start about the performance of this software. But at a technical point, it was actually not very maintainable anymore. This is all one large monolith. Had to be released as a whole. I think maybe once a month, something like that. We would have a release somewhere in the night for any new versions, any new updates. Wasn't the best of the best. The whole graphical client framework was end of life. We really had to modernize this. Just to give a bit of an image of how bad it was. This graph here, this shows all the dependencies between the different components of that one application at compile time. I'll be honest, our domain isn't the easiest. It is a bit complex, but trust me, it's not that complex. There's way too many components, which also means if you have a small change somewhere, the time you work on that small change is just super long, a lot of overhead. And also if you want to make a small change somewhere, teams were actually afraid to touch certain components because you would mess up so much. Pipelines were horrible. So it was pretty obvious something had to change. Everything had to change. There's been some failed projects just trying to pull apart some of these components wouldn't work, and eventually we just decided we're gonna do it all over. Just start over from the top. And I think the most important decision that we made when we started this new project was we're not gonna just start building this new and using new technology and trying to do it all over. We're gonna start with the teams and the whole new way of working. So where in the old way we would have multiple teams working on parts of the application, the deployment would be done by other teams. Now we would just put one team, a DevOps team, in charge of building this new backend. And that was their one clear task that they had. Build a new backend, make sure it's highly available, performant, maintainable. And so we said, yeah, sure, we'll do that. But on one condition, we want to have the freedom to do it our way. So we want to choose what tech stack we use. We want to arrange the processes that we think are essential for building a mission-critical application. And yeah, we kind of got our way. We were allowed to do it that way. So we went a whole new direction. One DevOps team turned into a couple DevOps teams. And we got a lot of responsibility with that as well, which also obviously means, well, we build the code, but we also deploy the code, we maintain it. And if something breaks, then it's up to us to fix it. So yeah, what does well, any self-respecting developer do in a case like that? They say, sure, we'll automate everything. So the whole pipeline is automated. If something breaks in production, we'll make sure it's self-healing, it's resilient. And if something does go wrong for whatever reason, at least we want to be alerted, so we're the first people to know before anyone else notices something went wrong. It started out with just a much cleaner, simpler architecture. We have way less dependencies. Took it all apart. Separate applications that you can deploy separately from each other. They have their own pipelines. They're released individually a couple times per day without downtime. Something about the tech stack we use. So obviously Java, Java Spring Boot application, Kubernetes and Docker just for the high availability, scalability, rolling updates. We use Elastic and Prometheus for our alerting and monitoring. Azure DevOps in combination with Argo CD for the automated pipelines.
And then you come to a conclusion with a new application that is working smoothly. And that runs. It was fine, it was great, and we were running this on an acceptance environment without any user knowing that we, or at least they were included, but we didn't they couldn't use it yet because we still had the old version of the software, the old BAM version running in production. And that was actually the most scary part that we were going to do. How are we going to get this software completely new, completely separate, its own data store, no connections to the old world? How are we going to get this in production? And you could imagine all our trains are running across the country, are going from sprinters to intercities. It's one world that is connected in all the places. So we started looking into something that we could actually extract from the current world and start using this new software on today. And in February this year, we started with NS International, with the Eurostar, which is actually a separate part of the company that is running our international trains to London, Berlin, and Switzerland, for example. And on February, we just took all the trains from BAM that are being used for these international services, and we started using them in BAM. That was the first big step. We were really proud on that. I think we did a week of on-hand support, also as the dev teams, on location in Amsterdam with the users. And that was actually pretty good received, pretty well received. And we started getting messages from other parts of the company, like, we would like to use this new software too. So we started implementing all the other train types already like a view on that. So we had the old BAM that was still being used to actually dispatch the new trains, to dispatch the trains, but in this new BAM, you could already see what was happening outside. And then on June this year, we started with Fleurtag, which is a separate small line between Gouda and Alphen aan den Rijn, which is actually NS, with some different branding. There are 6 train units that are going up and down one single train track, and sometimes they go to Leidschendam for service. But that actually worked as well. And then we started thinking, we would like to do something, some next step, but we don't want to do it like a big bang. But how are we going to do it?
You're talking about the Big Bang.
Yeah, because we couldn't break it any smaller. All our Sprinter stock is running in Intercity stock. Intercity stock is doing Sprinter services. So that was all tied and connected.
Yeah, so I guess we had like 10% maybe. I'm not sure about the numbers. A small amount of all trains was already live using the new BAM. And we had a date for the rest of the Dutch trains. So on September 25th, we were going to go live. Well, we did go live eventually, spoilers. With all the rolling stock in the Netherlands. We were hyped. It was just going to be going live
2 times, right? Was it
well,
easy thing?
We'd already did it twice,
yeah.
Sure, and we're just doing it during the day. So at 11 in the morning, that was the time for us to go live. And then on the day of going live, issues everywhere, especially around Schiphol. So some of the overhead lines broke. A train got stuck somewhere on the rails. Lots of disruptions everywhere, which also means that the users of our software are really busy trying to fix all these issues. So we were sweating a bit. Not sure if we were even going to be allowed to go live, but luckily the business, they had enough confidence in how we'd done these few live moments before, that we were allowed to go live just on the 25th during the day, where usually even a normal release would be at night, take a couple hours. Here we were just before lunch, going live. Everything went smoothly. That's pretty much it.
Yeah. So some numbers. Was it a success afterwards? I think we have a success. We did more than 20 releases in the first 7 days, and that compared to BAM, that in all of its lifetime did almost the same number of releases, without any downtime this time. And in the old world, we had always some downtime. Currently, at that first week, we had, like, from all the different locations in the country, we got more than 200 user requests and improvements that we were able to fix. Currently, we are on average, we have like 180 real-time users, and that's actually growing because this application is far faster in giving you a response. So more people within the company start using this application instead of other tooling that they have. And we have now like 4 million searches every day, which like I'm looking for this train, I'm doing this thing, and that's from service maintenance people all over the country, which is actually pretty cool. And like it was already mentioned a few times, 15 minutes is pretty short. We want to show you way more about the new BAM application. So we came up with a webinar. If you go to werkenbij-ns.nl/deep dive, you will actually also be able to see this. It's the same as QR code. Next year, the 29th of January, we will present a deep dive into the BAM application.
That's right.
Thank you.
Thank you so much.
Thanks.
That concludes the bite-sized session for the Innovation Award. So I bid you all a very nice rest of the JFOL and give these nominees and winners one big last hand, please. Thanks so much.